They would just be fresh. Stay strong, stay safe, stay at home. Stay at home ya. Stay at home.
𝗔𝗰𝗱𝗻𝗄𝗆を体をお大事に。
Assalamualaikum and a very good morning to everyone. I am Diana from IK Academy and I would like to welcome all of you to our webinar of the Learn with IK Live series organized by our iClub by IK community page in Facebook. Do join our community page and don't forget to invite other people so that everyone can gain something beneficial from it. Just go to the page and click join. As a friendly reminder, please register yourself through Eventbrite to make sure that you won't miss any notification for our upcoming event events and as a record purposes that you have joined our webinar today. If you have any question to ask about this, just type in comment. Our crew will attend to your question. And also, don't forget to type #IK Academy. I would like to say thank you to all our returning audience and to those who are new. And this is the first time that you heard about us. We are a technical training provider. At IK Academy, we train and we integrate knowledge technically. Neutrality is our priority. We are totally brand neutral with a strict focus on education. Our training programs cover power, maintenance, environment, building facilities, mechanical, electrical, project management, and more. We are committed to provide the best learning experience to everyone. We believe learning is a lifelong process. Before we proceed with our webinar, please like and share this live webinar with those who you think will be interested with our sharing today. You may click the share button and share it directly to your FB page, or you may share along the link via WhatsApp, Telegram, or any medium that you may find, as long as it can reach to as many people as possible. And also, like I mentioned just now, please type #IK Academy in comment to show your support and also your presence today. So today, we will have a webinar with the title of Carbon Footprint Reduction for Manufacturing Industry. Our invited speaker, who is a world-leading researcher in process integration for resource conservation, will share his knowledge and experience with us today. So let me read a bit about his profile. So Professor IR Dr. Dominic Fu is a professor of process design and integration at the University of Nottingham, Malaysia. He is fellows of the Institution of Chemical Engineers, ICHEME, Academy of Science Malaysia, ASM, and Institution of Engineers Malaysia, IEM, as well as the president for the Asia Pacific Confederation of Chemical Engineering. He is an active author with 8 books, more than 450 journal and conference papers. He is the editor-in-chief for the Process Integration and Optimization for Sustainability Springer, editors for Process Safety and Environmental Protection Elsevier, South African Journal of Chemical Engineering, among others. Prof. Dominic is Innovator of the Year Award 2009 of ICHEME, Outstanding Young Malaysian Award 2012, Outstanding Asian Researcher 2013, and ASM Top Research Scientist Malaysia 2016. He conducted more than 100 professional workshops to academics and industrial practitioners worldwide, including those in UK, South Africa, Australia, Singapore, and Korea. So we are delightful to have Prof. Dominic together with us today. So Prof. Dominic, maybe you can switch on your camera and also unmute your mic.
Good morning.
Good morning, Prof. Dominic.
Hi.
How are you?
Good, thanks, Diana, for the kind introduction.
If let's say I miss out anything important about your profile, probably you can add up a bit, no problem.
More good enough already lah.
Okay, so everyone here, please say hello to Prof. Dominic by typing in comment, and also don't forget to type #IK Academy. So are you guys ready for the webinar? Because I am. And again, I will appreciate your help to like and share this live show to everyone that you can think of. Or probably you can share in your community page in Facebook, LinkedIn, or anywhere else now so that they can join us together. And if you have any questions throughout the webinar, feel free to type your question in comment section anytime, and I will read your question accordingly. So I guess we can start. You can share your slide.
Okay, let me know if you see my slide.
Yes, I can see your slide.
Okay, and is that moving?
Yes, correct.
Okay, good.
Okay, good to go. Okay, enjoy everyone.
Thanks, Lena. Thanks, Diana. Right, good morning, good afternoon, or good evening, depending which location are you located. Today, our webinar entitled Carbon Footprint Reduction for the Manufacturing Industry. Dominic Fu, I'm delighted to talk to you. Thanks to Diana for hosting this. Today, we have about less than an hour, so I'll briefly talk about climate change and a bit of an introduction about the techniques that we use. Then I'll cover the method that was developed about a decade ago for carbon footprint reduction, and then cover 2 case studies. It depends on the time that I have in terms of the depth. I'll see what I can do to introduce you 2 different cases. First of all, I believe some of you have seen the some of the extreme weather incidents getting worsened in recent years. the country that is not too far from us, Australia, they encountered some bushfire in recent years. Bushfire is not something rare. It's not something rare in Australia. It's quite common. The only thing is that the last 3 years, their bushfire is getting more and more serious and cover more land area. For instance, this was 2019, and that burns about 46 million acres of land and destroyed more than 3,000 homes and more than 30 people. It lasts for quite a long time. You can see the duration. Eventually, the fire was pulled off because of heavy rain. But the heavy rain, once they pull off the fire, it causes a flood. And you probably also realize that different parts of Australia are facing flood problem in the past 2-3 years, getting more serious. And similarly, in the other parts of the world, places like California, the wildfire is also not alien for them. It's getting very, very common. There's Golden Gate Bridge, where it is covered by the dust. So that's why it's very reddish. In different parts of the United States, in the north, they have bushfire. In the south, they have Arctic blast. If you do remember the last year during the world lockdown, during COVID, they encountered double sort of issue, because when a hot place like Kuala Lumpur suddenly hit by snow and all the pipeline were broken because they were not designed to encounter very, very cold weather. So water pipelines was broken because ice frozen, and they also have shortage of oil because some of the blockage of pipeline as well. Of course, back in our country, Malaysia, some of this is no more what we call rare incidents. Okay, extreme floods, sudden floods becoming a common thing for us here. Okay, that's the statement by the ex-Director General, who expected that the extreme weather are going to be more frequent in the near future. You can expect that temperature during the dry season become hotter and rain become heavier. Okay, and this is going to be very frequent. And he actually stated this back 4 years back. However, we get to experience it now and then. Okay, every now and then. Those are pictures for Kuala Lumpur downtown that were caught in flood. One of this reported data 2 months ago, for a sudden flood that happens in Kuala Lumpur downtown. You can see the red color highlighted section near to about 10 places in the city of Kuala Lumpur were flooded with huge amounts of water downpour. Out of those are the high peak region, and this happens in a very, very short time. Okay, you can say, for instance, some of this more than 100 mm of downpour, those occurs within an hour. Okay, some of those only 45 minutes. So back then, we also have heavy downpour, but it's usually less in terms of volume and drag a longer time. Now looks like the heavy downpour come in with a large volume in a very short time frame. So whatever drainage system that you design will not be able to cater this kind of sudden change in weather. Okay, whether you like it or not, these are getting norm for us. Okay, you can see this is within an hour kind of basis. Okay, getting shorter and shorter with a large volume of water. So, well, actually, more than a decade ago, some climate scientists already told that there are some issues that we need to be careful. Okay, they actually proposed the sustainable boundaries for Mother Earth to sort of operate safely. One of these conditions is actually climate change, in which the CO2 concentration in the atmosphere is used as a parameter. They say that if you want Earth to operate in a sustainable manner, please make sure the CO2 carbon dioxide concentration is kept within 350 parts per million by volume. Okay. However, when they published the paper in 2009, the value was already 387. Okay, already exceeded. But you don't see that kind of extreme weather a decade ago. Only until recent years you see this, because all these are actually delayed. Okay, you will delay. Okay, when they say proposed boundary is 350, you know what are we now? Some years ago, we actually already surpassed the 400 ppm threshold. Okay, this was 2013. Okay, where 400 parts per million threshold has been bypassed. Okay, they actually proposed 350, but 2013 already 400. And I captured the picture a month ago. It was reported 417 2 months ago. I'm sure now it's higher than this value. Okay, it's probably 418 or 419. Okay, and by the way, it's fluctuate every year because of the spring and winter kind of situation in the northern hemisphere that cause the flora to absorb more CO2, and then it will absorb less CO2 because of the winter season. Okay, but overall, you can see that the trend has been climbing. Okay, this is known as the killing curve, going after the name after the scientists who installed the measuring device at Hawaii. Okay, back in 1950s. Okay, which nobody thought that CO2 can be a culprit for climate change back then. Okay, so many years ago, he already installed the device and he monitored it until he passed away. Okay. So you can see that the overall trend is increasing. Okay, people always say that, whatever year is the hottest year. Actually, there's no hottest. There's always hotter and hotter and hotter in the future. So, of course, some of those things happens, like for example, the melting of ice. Again, this was a picture taken last year for the largest world iceberg that broke off from the Antarctic ice shelf. Okay, you can do a Google search, you can find all this. This was a picture taken when it was across, I think, a month or two, something like that. Okay, and that melting of iceberg eventually will lead to incident like sea level rise. Okay, some people actually put this in one of the seaside, if not mistaken, in Australia. They say that some years from now, you're going to expect the sea level to be rising, and there's no more beach in the future. Okay. In fact, in Malaysia, we also encounter reports saying that a lot of the coastal area, okay, in the peninsula, this is the more serious place. You can see that all the red dots are region which will eventually flooded with water in 50 years. And the next 10, 20 years, you are going to experience more and more flood. And some experts say that you're going to expect at least once a year where the flood will come. Okay, so last year people were saying that, COVID will help us to reduce CO2. Yeah, it does, but not much actually, because the global CO2 fell only 6.4% in year 2020 when the whole world locked down, stopped all the activities. Okay, and we need much more than that in order to achieve climate change reversal. Okay, the world need to cut 7.6% per year. Okay, in order to keep the global warming not higher than 1.5 Celsius. Okay, and by the way, the picture of the background actually shows Himalaya during the lockdown. You can see Himalaya with naked eye, because in normal time you won't be able to see too much dust. Okay, that block it. Okay, and these are some reports by the scientists that says that climate change will have to happen unless we have lockdown every year. Okay, you see that this was a global lockdown. It does help to reduce CO2, but as I said, not sufficient. Okay, we need something more drastic in a post-COVID world, because we are now ramping up everything. Okay, economic growth, all this, and usually economic growth are associated with energy. More energy that you use, more CO2 is coming out, and we need something called technology wages, in which all this so-called future and current technology are to be implemented in order to cut down the CO2. Okay, we are now here already. Okay, we are trying to achieve 2050, in which many countries have announced the carbon neutral targets. Okay, if possible, we want to increase the use of renewable. We want to start switching to cleaner electricity, improve the electricity efficiency, and all this should be coming into picture. Okay, and of course, a lot of people are also talking about carbon capture. As of now, there are only 2 or 3 big scale power plant, big scale CCS plant are running. Okay, and many others are in demo or pilot scale kind of transition period. So still yet to be in large scale implementation. Okay, this is another new technology. We call it negative emission technology. People start talking about it 10 years ago. Now it's still in the research stage, I would say, still not there yet. So we can only rely some of those technology in the middle here. Okay, so trying to make use of this techniques. Okay, nuclear is a controversial one, even though it does not produce CO2, but then it is a safety concern. Okay, of course, the United Nations released the Sustainable Development Goal in 2015, in which some of those things are highlighted. Okay, Goal 7 says that we need to produce available and affordable clean energy for everyone for usage, and Goal 13 talk about climate change, in which CO2 need to be removed, okay, from the Mother Earth in order to keep the temperature rise below 2 Celsius. Why 2 Celsius? Because 2015 was the year where they signed the Paris Agreement, in which is to keep the global temperature rise below 2 Celsius above pre-industrial level, and pursue an effort to rise to 1.5. Okay. This is a follow-up in Glasgow, the COP26, 2021 December, and they again reassure that we will want to have the 1.5 Celsius growth, okay, if possible, try to keep it at 1.5. That is the eventual target, okay. Okay, meaning that we should only allow the temperature of the Mother Earth to go not higher than 1.5 if possible. Okay, in the industry that I serve, the chemical industry actually consume a lot of energy, okay, and predominantly fossil energy, okay, coal, and then natural gas. All these are fossil energy that produce CO2, whether you like it or not. The technique that I'm going to introduce to you, how can we cut carbon footprint, is called process integration. It was introduced back in the 70s for heat recovery system. Back then, this was the first oil crisis of the world, and this technique was proposed by some of the important technology developer. Okay, back then, 1970s, it was meant to reduce energy usage, and nowadays, for us, reduce energy usage also means reduction of CO2. Okay, that means carbon footprint reduction. Throughout the years, in the last 40 years, these techniques have been extended to address things like solvent recovery, water recovery, optimization for production train, and then hydrogen integration, solvent recovery, and eventually CO2 optimization. Okay, for those who are trained from chemical engineering or mechanical engineering background, some of this diagram is not alien to you. This is the heat recovery system where the hot streams can be used to recover energy to the cold streams. From there, we can identify how much hot utility needed, how much cold utility needed. The minimum hot utility corresponds to minimum CO2 reduction as maximum CO2 reduction as well. Okay, and the technique was extended to water recovery. You can plot something like this to identify how water can be recovered. Okay, these are some of the very basic fundamentals about process integration. Of course, if you're keen to learn about it, these are some books that you can pick up. For energy recovery, I would suggest this book. Okay, this is a very good one for you to do energy optimization, because apart from CO2 reduction, you actually reduce operating costs of the plant. Okay, let me move on to talk about carbon footprint, which is the main topic for discussion. All the products that we make, be it whatever, water bottles, the clothes that you wear, the gadgets that you use, the computers that are used now, all this contain some carbon footprint, whether you like it or not. Okay, and when we produce it in our factory or a plant, we embed our carbon footprint through our raw material, our power supply, and our steam. Some of these are external things. For example, raw material, this is always external. Electricity usage, obviously we buy it from the utility supplier, and steam, you usually generate yourself after you purchase the fossil fuels from your supplier. Okay, so if you generate steam yourself, obviously this is an internal carbon footprint that you add to your product. And if you purchase something from outside, like electricity or raw material, these are external carbon footprint. So all this footprint will go to the product and you sell it to your consumer. A decade ago, we proposed a method. This was not new. Okay, even people didn't even talk about carbon footprint. This method already being proposed and already out there, and some companies are using it. What it does is ask you to plot a simple diagram, CO2 emission on the y-axis and economics on the x-axis. These economics basically are the costs that you will add on your product. Okay, let's say for example, you have a raw material that you purchase from your supplier. That is the cost for raw material, and you are also generating steam, okay, for usage. Okay, that add value to your product, and every value that you add, you are adding CO2 emission, whether you like it or not. Okay, this carbon footprint can be divided into internal and external, as I mentioned earlier. Anything that has a high internal or external footprint, we will have to think about some method to reduce it. In the diagram that you see, this is one of the scenario where internal footprint is higher than external footprint. How do we know that? Because this blue line, again, this blue segment, the internal footprint portion has a higher slope, meaning that for every dollar and cents that you add to the product, you're adding higher carbon footprint as compared to the external part. Okay, in other words, your raw material, your power supply is the external, is you are also adding CO2, okay, but it's not so high in terms of intensity per dollar and cents compared to the internal that you add in. Okay, so when your situation is having a higher internal footprint, we need to do something about the internal footprint, trying to reduce this in order to meet our target. Okay, what is our target? This is the one. Okay, this blue green line, the demand composite, is the target that we're trying to achieve the carbon intensity benchmark. If I can reduce this point to here, I at least achieve the goal that I want to that I set within the company. Okay, so of course it depends on your investment, on the clients that you deal with. If you're trying to send this to a European market, you want it to be clean enough, okay? Because the European customer are usually very concerned in terms of environmental footprint. So for this case, when your internal footprint is high, what we can do is to think about some options that we can reduce the internal footprint. I'll talk about that later in the case study, because different case study may have different scenario. If I can reduce the carbon footprint from the top right end down to meet the target that I set, okay, I will be able to reduce the carbon footprint, the overall carbon footprint for the product. Okay, but you also notice that I didn't touch here because this has a lower intensity. Per dollar and cents, its CO2 emission is lower compared to internal, so I don't have to touch this. As long as I can get rid of the internal footprint, I am fine. I'm very okay. Okay, I've achieved my target and I move on. Okay, this is one of the case. In a different case, when you have internal footprint and external footprint, however, the external has higher intensity, what we need to do is to reduce the carbon footprint for the external. And the moment this is reduced, the internal will also go down, and hopefully it achieves the targets. Okay, let's say for instance, I'm showing you an animation. I'll cut down the external. Okay, I cut down this portion. This was the original portion. If I can cut it down, I will be able to bring the internal footprint line down here. Eventually, you meet the target. Okay, this target is depending on your nature. As I said, if your client says that can you reduce 10%, oh, I'll do 10%. If your client says, oh, can you reduce 20%, oh, I'll do 20%. If your boss says that, oh, I only have $10,000 US, I can do whatever you can. Then we will evaluate the options that we have, and we'll see whether it can achieve 10% or only 5% or only 8%. It depends on the situation, depends on the options that you have, and you work based on your constraint. Okay, so these are the two different cases. This is the case where external footprint is high intensity. We have to cut it down, and so that the overall footprint can be reduced. Okay, I'm going to show you two case studies in a very superficial way, hoping for you to roughly capture the idea. This is a case where a product called tongkat ali is made. Okay, I believe most Malaysians will know what tongkat ali is. In the process plant, they will put the tongkat ali in the extractor and then put in the ionized water, cook it for 2 hours within a pressurized vessel that operates at 2 bar. After that, they will send it to a tank and then to be spray dried. So this final product is a dehydrated extract in a powder form. Okay, very, very bitter. Okay, once you spray dry it, it become. Oh, by the way, after you extract it, it's a yellowish liquid. Again, this is Tongkat Ali roots, and you cut it down into small little chips. Once you spray dry it, it become a yellow color powder. And because there's no more liquid water, this is pure Tongkat Ali powder. If you put in 40 kilogram of Tongkat Ali extract into the extractor, the moment you spray dry, this is only 1 kilogram. From 40 kilogram roots, you dry up to 1.2 kilo. Very, very concentrated. Okay, this is very bitter. Even you just walk into the room, you can feel the bitterness at your throat. Okay, that's the extractor. That's a spray dryer. Once you collected the spray dried powder from the vessel, then you can pack it, and then it goes through some operations or packaging, and then eventually you can sell this product to the clients. Okay, this is a model that we built in order to obtain the mass balance, how much Tongkat Ali is coming in here, how much fresh water we put in here, and we need some evaporator and spray dryer and some packaging machine to get the final product. Now, what we need to do, based from the analysis, we capture all the feedstock needed. Okay, we need water, chill water, maltodextrin, Tongkat Ali root chips, bottle boxes, and from there we calculate the costs to make such a product. Again, let's say this is 14,500 material costs per month, and we then calculate the electricity and steam costs. Again, that gives us the cost for electricity. With the steam and electricity, we can also calculate the carbon footprint for the different materials. Eventually, we know that this particular production plant, every month they are releasing about 9 metric tons of CO2. Okay, and the energy footprint is calculated based on the electricity. Okay, electricity mix. This is the power mix in Malaysia. Okay, 10 years ago when we did the analysis, our power mix in Malaysia is 50% natural gas, 35% coal, hydropower is 14%, and oil is 1%. Nowadays it's slightly different because we have more renewable. So, but with this percentage based on the intensity, you can actually calculate the carbon footprint of the power generated in Malaysia. Nowadays, I would say this is cleaner because we have a bit more solar power and renewable also coming in. So this is cleaner nowadays. Okay, but once we know the power generation mix carbon footprint, we can then calculate the carbon footprint for the energy. Okay, once we have those things, you can put it in the table form, and then you can try to plot the graph. I'm showing you the carbon footprint graph that plotted for the for the Tongkat Ali case study. This is material, meaning that the Tongkat Ali roots, boxes, bottles, all the carbon footprint brought in by those raw material. Okay, you may wonder why Tongkat Ali also consists of carbon footprint, because it has to be sent from the jungle to the processing site. Okay, and when the lorry send the roots over, it's going back with an empty lorry. So it releases CO2 because it's running on diesel. Okay, and it's not so bad. Again, material base is not too bad compared to energy. Steam and electricity is the main culprit in this case. You can see that very little cost-wise is little, but then CO2 is very high. Okay, so per dollar and cents, okay, this has a very steep what do you call that, segment. It also means that the carbon footprint is very, very high. Okay, what we can do is to relook at what contribute to this by plotting another graph. Okay, once I plot this graph, then I'll know that, oh, this is actually the electricity that we purchased from Tenaga Nasional. That's the power producer from Malaysia mainly, and then the internal segment is contributed by steam usage of the plant. If you are going to aim for 10% reduction, okay, this 10% reduction is coming from the overall what do you call that, footprint in the earlier slide. Okay, that is going to be 1.4 metric ton per month. Okay, if my energy my energy base footprint is 4.7, if I want to cut down 1.4, that also means that I need to achieve 3.3, which is the target given by the red line called the demand composite curve. We need to achieve these final targets. Okay, how can we do that? Okay, we re-look at the process at the moment, and when we did the analysis, those guys to them, they will just extract whatever they want for the product, sell the product, dump all the waste. Okay, I told you that every batch of the product that they make, they put in 40 kilograms of tongkat ali and they produce 1.2 kilogram. Okay, this is per monthly basis. You can see that they are using about 3,000 plus kilogram per month of tongkat ali roots, and they produce about 28 kilogram of powder. Okay, of tongkat ali powder. That also means you have a huge amount of fiber, wet fiber that we are dumping away. Okay, out of 3,166 kilogram, they are dumping 3,040 kilogram of roots. Okay, sorry, the font may be too small for you, because the yield is only 3%. Okay, every 40 kilogram you only get 1.2 kilogram of powder. The other 38.8 is solid waste. Okay. That time during they started the analysis, that was not a problem because after all, carbon footprint was not a big issue. However, nowadays they are trying to look for options to improve the product. Okay, so what can we do with the fiber that were generated in the plant? Okay, there are two options. Option one, we can make use of the fiber to generate power. After all, we are using some electricity in the plant. Okay, if I can dry up the powder, the fiber, I will be able to blend with the I can put it into a steam boiler and then generate electricity from there, and that will reduce the electricity that I have to purchase from external party. Okay, option one. Option two, I can also dry up the fiber and then put it into a boiler to generate steam. So either I generate electricity or I generate steam. Both of these will cut down my external consumption of utilities. Okay, if I generate power, meaning that I buy less electricity from outside. If I generate steam, I will be able to reduce my fuel oil that we'll use to generate steam in the first place. Okay, so both of these are possible, and we'll look at the economic part to see which one is a better solution. Okay, and we do a simple analysis for power generation. If you carry out the analysis, you will see that CO2 reduction wise, we can actually reduce the CO2 by more than 10%. Okay, more than sufficient to reduce 10% of the overall carbon footprint. Okay, the only problem is you will have to buy a new power generator. The investment is not cheap. Okay, in terms of carbon footprint, it can achieve more than 10%. It's close to 11%. Okay, but investment is high because you will have to invest in a new power generator, because the plant originally is just buying power from outside. They don't have a power generator. You have to buy a new one. It's not cheap. Okay, that's a lot of investment. Option two, if we were to generate steam, what we need to do is to put the steam into a dryer. Okay, of course we can put it under the sun. Okay, as long as it's not raining, it's fine. And or you can also purchase a tray dryer, dry it. Okay, first, then only you put it into a boiler. The boiler can generate steam usage and to be used for the plant. At the moment, they have a boiler. Okay, they are generating the steam using fuel oil. And if we want to make use of the fiber, we have to make sure the fiber is small enough in the first place. Number two, need to dry it because it is quite wet. Okay, it's about 50% moisture content. It's very, very wet. Okay, we have to dry it before we can put it into the boiler. Okay, and of course you will argue that, oh, if you dry it using tray dryer, this is also releasing CO2. Yeah, right. Okay, so we need to look at it carefully to see whether this is how much reduction is there. Okay, but if you can make use of the fiber, okay, that actually cut down the external fuel consumption because they are buying fuel oil from external party to generate steam. Okay, if you use fiber, you can do some calculation, assuming the heat content of the fiber and then efficiency of about 50%, moisture content is about 50%. Because of the high wetness, okay, 50% wetness, CO2 reduction is only about 9%. We won't be able to achieve 10%. Okay, but if this is something that is feasible, okay, we can look into the details and do a bit more modification on the existing system to move forward for these options. Okay, technically this is a more viable options compared to power generation. So the clients actually feel of implementing this. Okay, we leave them to do the job. I have some time. Let me share with you second case study. This was based on the plant in the northern part of Malaysia. This plant produce chlor-alkaline product. Okay, they are using salts. Okay, and they imported the salt from Australia, passing through some processes. The main process in the plant is electrolyzer. They put in the salt and then put in the mineralized water, make the salt become salt water, and then pass through electrolyzer that produce NaO, sodium hydroxide, and some chlorine gases that will send to the hypo tower and HCl burner to produce other products. Okay, now for this particular plant, the electrolyzer is the main power consumer. It consumes about 90% of the electricity, and the reaction is given here. All right, this is what happened in the electrolyzer. Chlorine gas and hydrogen and sodium hydroxide, the main product coming out from the plant, because of the electrolyzer are quite old, their power consumption is actually very, very high. Okay, and if you do the analysis for their carbon footprint diagram, you can see that material is not too bad. Okay, even though, but I mentioned that they imported the salts from Australia. The reason was that they say the seawater in Australia is actually cleaner in terms of less mineral, that the unwanted mineral. So they have to import the salt from Australia. So when you import the salt from Australia using sea transport, that release some CO2 as well. Okay, but still, it is much less than the energy portion. Okay, why? Because they use a lot of power in the plant. Okay, for the electrolyzer. Okay, if they want to reduce 10%, okay, that 10% is based on the total 5,000 over. Okay, for the total CO2 footprint. 10% also means that they need to cut down 500 over every month. Okay, 500 tons every month, and we then see that the energy portion is the main culprit. Relook on the energy portion, you can then see that the electricity part consumed the main by the electrolyzer. So if I want to implement 10%, that also means that we need to cut down the carbon footprint for energy portion by about this much. Okay, 500 over. That have to reduce down to 3,600. Okay. That's our target. However, may not be that easily implemented because the internal segment is this, external segment is this. If you want to reduce down lower to this value, it's actually even lower than the external segment. That also means that we have to cut down the electricity footprint as well. So in this particular case, we propose a dual approach. Number one, we have to reduce the slope of the internal segment, meaning that this internal segment that you will see here, this internal segment, we will have to reduce the slope. Reducing the slope also means that per dollar and cents, we release less CO2, hoping that when the slope is lower, we release less CO2. However, if the target is here, reducing the slope is insufficient. We also need to cut down the external carbon footprint. Okay, so option one, we reduce the slope of the internal segment by using some cleaner energy, producing some steam from the HCl burner. Their current equipment is not possible because it's a very old burner. The moment you pass by, you can feel the heat. It also means that the energy is not being preserved. Okay, if I want to reduce the internal segment alone is not sufficient, we have to also deal with the external segment reduction simultaneously. One option is to replace the electrolytic cell. Okay, the plant has been operated, I think, more than 40 years. Some of the cells are very, very old. Okay, and it's really not efficient. And you can see the picture below. What we can do is to slowly phase out some of the old cells by investing the new cells. Okay, the plant authority have thought about it, because in long term, when the electricity bill is getting higher and higher, maybe it's a better options to just replace some of the old cells. At the same time, we reduce electricity. That also helps us to reduce CO2. Of course, there will be capital cost investment. Okay, in some countries where there are options to pursue green electricity, they can also look for options to buy electricity from clean energy producer. Unfortunately, not for Malaysia. Okay, so there are also options that we can put in solar cell on the rooftop. Okay, if you can put solar cell on the rooftop, that also can help you to generate green electricity. Those are options that we can pursue. Again, if you want to put solar cell, money is needed. Okay, investment are needed. Okay, if we're going to implement the two options, reducing the internal segment footprint, this will reduce the slope and will cut down the external footprint a bit. Okay, meaning that we will not buy so much electricity by changing some of the electrolytic cell. Okay, that will cut down the power consumption, and you can see that if external footprint can be cut down, this internal footprint have its slope reduced. That will help us to achieve sort of the targets that we set now, about 10%. Okay. Again, this is potentially doable. Okay, whether to implement or not, we leave it to the plant authority. They will have to decide whether that such an investment is necessary, or whether they can get a loan from the bank and for the HQ, or from whatever green financial scheme by the Malaysia Green Tech Corp. So those are options that we can consider. Okay. Finally, I'll spend 5 minutes to talk to you about this multi-product. The two case studies that I encounter, they are considered as single product. Okay, single product means that if I can do the footprint reduction, it will have a significant sort of contribution to all my processes and my products. Okay, for example, even the coal alkaline plant, even though they produce 3 different products, but they are all sharing similar facilities. If I can get better improvement of the electrolyzer, okay, this electrolyzer, as long as I can improve the performance, okay, I can cut down the electricity consumption, that will benefit all different products coming out from there, because this is the main process that will contribute to different products. Okay, so to us, for in this particular method, we consider this as a single footprint reduction strategy. Okay, there are some cases where this method may not work efficiently. For example, when you have a process where multi-products are coming out, we need a slightly modified method in order to cater for multiple processes. Okay, this paper is relatively new, about 2 years old. Let me show you. For example, if you have 4 different processes producing product X and product Y, A and B, they are shared processes. Okay, meaning that if anything that you modify, any retrofit that you do here, that will have it will affect both product X and Y. However, if you only modify product C, process C, it will affect product X. If you do any modification on process D, it will affect product Y. Okay, these are dedicated processes. Okay, we say A, B are shared facilities, C and D are dedicated facilities. Okay, because C only produce product X, D only produce product Y, and this C and D has a significant CO2 emission as well, meaning that their carbon footprint are significantly higher for C and D compared to A and B. Okay, so it could be a case like this. Okay, of course, this can have several strategies to deal with that. First of all, we look at whether the shared facility has a higher carbon footprint, or whether the dedicated facility will have a higher carbon footprint. The strategy is different. Okay, for this case here, dedicated facility is higher carbon footprint compared to shared facility. If the shared facility has higher carbon footprint, then it's quite obvious. Okay, for example, the shared facility A and B have very high carbon footprint. We will try to modify or improve A and B in order to reduce the carbon footprint. Say, for example, this was the original carbon footprint. If you can reduce the carbon footprint, make it smaller, and you can reduce the overall footprint because C and D will be benefited. Okay. However, if the dedicated facility has a very high footprint, shared facility is lower, we will have to make sure that we look at process C and process D in order to reduce the carbon footprint, because doing shared facility may not help so much, okay? Because the intensity for processes C and D are higher. So these are the strategies that we need to adopt, okay? I won't have too much time to go into the details. If you are interested, we can send you a paper to have a look. Of course, you can join our workshop in the future. For concluding remark, I would say that when we try to reduce carbon footprint, it's important to look at the main contributors. Okay, if your contributors are the processes that is not efficient, if you can improve the efficiency, that will help to reduce the carbon footprint. Okay, we are looking for some systematic methods that we can address our work, and in using some visualization method that I've shown you, it does help us to visualize which processes has a higher intensity of carbon footprint. Okay, and we go with this motto called the big picture first, because any details that can come later is only making sense that when you look at the hotspots and address the problem from the root cause. If you're looking at the small little details that, oh, you have 10 processes in the plant, every single one you go and do inspection. But out of the 10 processes, 8 of them are not the hotspots, means that the reduction is not significant. It is just wasting your time. Okay, better look at the hotspots that contribute the most. Okay, that's the main philosophy on this methodology. Okay, look at the hotspots, look at the one that give you the highest intensity. So those are the processes that you need to work out, okay, in order to reduce the carbon footprint. Okay, we are the new generation engineer. We have to decide whether we want to keep living on Earth or migrate to Moon or Mars in the future. Okay, that's a picture for Mars. They say that in 10 years' time we can actually move there. Okay, but I do hope our next generation, my kids, my grandchildren can still live on Earth rather than moving to Mars. Okay, but the decision is yours. Okay, up to you whether you want to migrate in the future. Okay, I think I should make a stop here. Leave some time for Q&A. All right, pass the floor back to Diana.
Yes, thanks, Prof. Dominic. Yeah, I also don't want to migrate to Mars. Okay, so thank you, Prof. Dominic, for that.
Going there as a tourist is fine, I think.
Yeah, true. But migrate, that one, I don't think so. Okay, so thank you for the sharing, and we hope that you all learned something just now. So to everyone here, if you have any question to ask, please type your question in comment. As for the rest of you, if you don't have any question, just type hashtag IK Academy to show your support and also your appreciation to Prof. Dominic. So before we proceed with the questions and to give some time for everyone to write their question if there is any, I would like to highlight our upcoming trainings that you might be interested in as shown in the screen. This upcoming training will be delivered either online, offline, or both mode. Please scan the barcode shown and click on the link shared in the comment section to get more details. Okay, so let's continue with the question. Probably I proceed with the question that I got from Eventbrite. So the first question is this one from environmental consultant. What is Malaysia commitment on GHG reduction, and do you see whether it is achievable?
Well, as of 2005, we already submitted to Paris Agreement that we will do 35% reduction, and 35 plus 10, meaning that 35% reduction of intensity based on 2005 targets or something like that. Why 35 plus 10? Because back then we were expecting some developed country to give us financial, some financial aid to reduce another 10%. But as of last year, during COP26, we already told that we will implement everything and then cut down our CO2 intensity by 45% and without any condition. Whether people give us assistance or not, we don't care. We have to work on that to achieve 45% CO2 reduction intensity. Yeah, that's our commitment. Based on, I think based on 2005
2005,
GDP. It's per GDP, meaning that we need to check the baseline GDP at 2005, look at the in CO2 emission of that year, and then GDP of that year. And by 2030 later, we will achieve 45% reduction per GDP in 2030. Okay, so those are our intensity commitment.
Okay,
we
so
call it national intended reduction, something like that.
Okay, thank you. So I hope Prof. Dominic answered your question. Yeah. And another one is I think he wanted to you to explain a bit more about Scope 3 calculation methods.
By the way, I also should mention that we actually Malaysia actually announced that we want to achieve carbon neutral by 2050. Okay, that was announced, I think, end of last year, Q4 of last year. We actually announced that we want to achieve carbon neutral by 2050.
2050, yeah.
Yeah. Okay. The GDP reduction that I mentioned is 2030.
2030, right?
Yeah.
Okay, so this one is 2050.
Yeah, 2050 we will have to achieve carbon neutral. Don't ask me whether they will
achievable or not.
Yeah, but that's our aim.
That's the aim.
Still some years to come. Okay, 28 more years to come. Hopefully we can achieve that. But some statistics shows that if our 3 lines of MRT will be running, okay, the third one is not built yet. If all 3 lines of MRT will be running and with the maximum capacity, we can actually cut down our CO2 reduction a lot, because the main emission from Malaysia is actually transport. Okay, every house has 2 to 3 cars, isn't it? Yep. So if Klang Valley alone, if you can go on public transport, someone say that it's easily 20% or 20 to 30% easely. So
easily 20%. That's quite a lot also, 20%.
Yeah, and government also set a target to achieve 31% dependency on renewable energy by 2025, which means 3 years from now.
3 years from now.
To me, is a little bit too optimistic, but it's better than nothing. You set a high aim, very likely that we're not going to achieve it, but we have an aim there.
3 more years is too short, I think. 3 years is too short. Correct.
Someone asked about the third scope 3, right?
Yes, scope 3.
Before we talk about that, scope 1 actually means that I share a slide. Are you able to see that?
Yes, I can see a slide.
Scope 1 means for own production. Okay, this is scope 1. Whatever that's coming out from your own process is considered scope 1. Okay, your own vehicles, whatever things in your own company is scope 1. Okay, scope 2 is the electricity. So what we mentioned just now, you're buying electricity from DNB, you're generating your steam, those are scope 1. Buying electricity is scope 2. Scope 3 consists of waste, production, transportation, okay, purchase services from outside body, and then the sole products that you're selling to your clients and how they use it, how their end of life treatment. Okay, most company would not bother this. Okay, the sole product, because it's already sold to customer. However, if you have a mechanism to collect back the sold material, let's say there are some companies who have a trade-in kind of mechanism. You buy a new phone, okay, I trade in with the old phone with me. Okay, those kind of trade-in will help you to, you can actually look at the scope 3. If you don't have a trade-in system, you can sort of ignore this part. But there are also cases where scope 3 includes the transportation of raw material, like the second case study that I shown just now. The sort of the raw material of the company actually come all the way from Australia. You can imagine this is how many 1,000 kilometers distance. If you can source a nearby raw material, you actually cut down the carbon footprint of the transportation of raw material. That is scope 3. Okay, and how you handle your waste is also scope 3. If you can minimize the waste by recycling some portion of it, that actually contribute to scope 3. Okay, those are things that you will do lah. Okay, of course, last 2 years, because very little traveling, companies cut down the traveling budget because you cannot even travel. So that actually contribute to scope 3. But I'm sure now everybody start traveling again. So
Yes.
this is difficult. But if you have an options to go online, do online because that is a minimum reduction, minimum CO2. Okay, you just need to turn on the computer, use a little bit of electricity. That is a minimum CO2 compare you fly. Okay?
True.
Right. So these are scope 1, 2, and 3. If you can reduce electricity consumption, that is scope 2. If you can produce your own steam, that is scope 1. So these are all the options that you have. You can, as I said, if you want to look at your options based on your constraint, because different clients, different companies have different constraints. Sometimes they are limited with capacity, capex. Sometimes you are limited in terms of you only have one supplier. Whether you like it or not, you have to depend on that supplier. So this is something that you can't do much. Okay, but you can cut down the waste. You can try to find a better or more efficient transport system for your product. Okay, those can also help a bit here and there.
Okay. Okay. So I hope Prof. Dominic answered your question. Yeah. So I think we don't have any other question. So I guess we have come to the end. Any last advice or messages that you wanted to tell the audience, Prof. Dominic?
This what do you call it, carbon footprint or GHG emission reduction is getting more and more hot topic recent years because of the ESG thing. So options are there. Okay, I can tell you this is not something new. Okay, technology development in the last 20-30 years already good enough for us to implement the system. Okay, it's a matter of which one shall I pick? How can I do it? Is there a political will to do it? And also, before you actually do it, you actually need to do some simple calculation to check what is the benchmark. Don't compare your plant with another plant.
Yes, correct.
Even though this is the same company, you have a plant in India, for example, or America. Don't compare your GHG emission with the other plant, because your power mix in Malaysia is different from the power mix in India or US. Even though your production line is exactly the same, your feedstock coming from different parts of the world, your electricity coming from different suppliers, that will contribute to the CO2 emission, which is totally different. Even though you divide by kilogram of your product, it's not going to be the same basis. So do your own GHG emission calculation first before you look at how to improve it.
Okay.
So that's the thing.
Thank you. So probably can stop share first. Okay. So thank you, Prof. Dominic, for your sharing today. I believe all of us here gain lots of knowledge from you. So if you are interested to learn more from Prof. Dominic, because I think 1 hour is not that too long, so we have scheduled a session of physical training on 13 June 2022 about carbon footprint reduction for manufacturing industry. Please fill up the form via link that IK Crew shared in comments to get more details about this training, and we might have some special discount if you are really interested to join his training. So thanks again, Prof. Dominic, and to all of you here. Please leave some comments in Facebook and a thank you note to our guest speaker. At least we know that we share something beneficial to you, and also don't forget to type #IK Academy. So please like and follow our page in Facebook, LinkedIn, and Instagram, and also join our FB community page, iClub by IK, to get latest news for our upcoming IK Lab webinar series and also other content sharing. We'll be having the next one on Tuesday, 24th of May 2022 at 10 a.m. in the morning about indoor air quality. Do check our page for more details. Last but not least, please check your email for a thank you email via Eventbrite to get the link or barcode to retrieve your e-certificate, and don't forget to claim it within 3 days. Well, I hope I can see you again. Thanks from me, Diana from IK Academy, and stay safe, everyone. Before you leave, please watch this video from all of us from IK Academy. Bye-bye, everyone. Bye, Prof. Dominic. Thank you.
Bye, Diana. Thanks.
Bye-bye. See you.
See you.
Everybody. Hi guys.
Stay strong.
Stay safe.
Stay safe.
Stay safe, everyone. Stay together. くれぐれもお体をお大事に。